Question number 5. Reciting an example in each case, explain 3 types of mathematical equations whose degree of polynomial is greater than 0 and less than 4. Greater than 0 and less than 4. In that case, they want us to determine the mathematical equation whose degree is greater than 0 but less than 4. Now in this case, we can start number 1. Number 1 is linear polynomial. Linear polynomial. Why am I choosing linear polynomial as my first one? This is a polynomial having, this is a polynomial having the highest degree of 1 but not 0. For example, we can talk of can have a function, a general function of ax plus b, by 9 this x is just power 1. That is the polynomial of 1. This is just a general function I'm using. Then number 2, we can talk of quadratic polynomial. That is a quadratic having 2. We said that is a polynomial. It is a polynomial having its highest degree of 2. For example, we can talk of a function like f into x is equal to 2x squared plus 3x plus 15. Now this one is having the highest at the power of 2. Then number 3, because we are told that is greater than 0 but less than 4, we can talk of number 3. And the last one, we can talk of a cubic polynomial. Cubic polynomial is a polynomial having the highest degree. It is a polynomial having the highest degree of 3. Example, you can talk about the same example. I use this particular function whereby fx is equal to 8x cubed plus 2x squared minus 3x plus 15. Now in this case, the highest is power 3 followed by 2. And the quadratic, the highest is power 2. Linear, the highest is 1. That is what they wanted. They wanted the one whose has is greater than 0 and less than 4. Those are the 3 good examples of the mathematical equations. Then part B, the following raw data shows the marks scored by 40 students in a statistic test. Required present above data in a grouped frequency distribution table starting from the class of 50 to 54. I'm going to use exclusive method, whereby we are going to include, for example, 50 to 54, then 54 to 55, 59, that is we're having a class limit at a class interval of 4. Now here we are having, now the first one you are told that starting from 50 to 54, that is my class. Now the highest, the other thing you have to establish the highest. I'm assuming the list should be in that particular bracket. Yes, the highest from this particular table, I'm saying that is 88. That is my highest. Therefore, we can talk of this plus 4 54. 54. Can have 54 to 58. 58 to 62. 62 to 66. 66, we are moving to 70. 70 to 74. 74 to 78. 78 to 82. 82, 86. 86 to 90. 86 to 90. Then here I'm going to have tally, frequency, and then I will have something to do with the cumulative frequency. Now 58 falls under this one. Yes, that's one. 69 here. 72 should be here. 83, this one. Shed 70 is here. 62 is here. 68 somewhere here. 75. 67 is here. 71. 71 again. 53. 62. 82. 78. 61 somewhere here. 72 is here. I post this one. 57 somewhere there. 68 is somewhere here. It's 4. 74. 66. I close this one. 65. 87. 72 should be here. No, it is here. 72 again. 60. 76. Let me use that one, the one I had deleted. 63. 74. 79. 67. 77. Close. 66. 81. 73. 68. 73. 64. Close. 88. And then 72 again. That is 5. I close. Now my frequency is when we hit 50 to 54. According to my list, we hit 1. 54 to 58, we hit 1. This one we hit, that is 3. Alright, 62 to 66, we hit 5. This one we hit, that is 5, 7, 8. This one we hit 10. This one we hit 5, 2, 3, 2. That is what? Just use those lines so that you don't get confused. That's 3. That is 5, 8, 10, 5, 2. I guess it's a bit clear now. Now we can determine the cumulative frequency. We have that is 2 plus 1 plus 1, we have 2. Plus this one we have 5. 5 plus 5, get 10. Plus 8, have 18. Plus 20, have, that is, should be that 8. Sorry, 28. Sorry, yes. Plus 5, that is 33, 33. Plus 2, that is 35. Plus 3, 38. Plus 2, that is 40. It's matching if we are told that we had 40 students. Now presented that in the frequency distribution table, we have done that. The number 2, they say that present the result in B above in an ogive graph. Now in that case, we have to draw an ogive graph using the cumulative frequency alongside the class. And in that case, I'm just going to sketch. I'll just sketch here. This now on the y-axis we are going to have the cumulative frequency, and then on this side, the x-axis, we are going to have the classes. Class we are starting from 50 to 54. Now we use the upper case. We just assume that we start from 0. Now at this point, I'm going to break this particular line in that order I'm starting from 50, just to guess at 50, 50, 54, then we hit that is 58, 60 in that order, 58, 62, 66, 70, 74, 78, 80, 84, sorry, this is 82, 86, 90. And then this 40, I guess which scale will be favorable for my case. 10 will be 20, let me use 5. Is 0, is 5, 10, 15, 20, 25, 30, 35, 40, 45, and so forth. Now we can start sketching that particular graph. We hit 54, we hit 1. Now 54 here, 1 is jumped somewhere slightly there. Then 58, we hit that is 2, slightly above 1, that is 2. And then 62, sorry, that is 58, 62, 62 we had this one 5, 62 we had 5, yes, but you can draw it correctly using the graph paper. And then we have 66 we had 10, 66 we had 10, 66 we had 10, 70 we had 18, 70 we had 18, 70, 18, just slightly below 20. I'm assuming that we start on. Then 74 we had 28, 74 we had 28, above 25 should be there. And then we had 78, that is 33, 78, 33 below 35. And then we had 82, 35, 82, 35. And then 86, we had 38. That 8, and then we had 40 somewhere there. That is 90, we had 40. Now when you draw your graph, an ogive graph will start from this point, then it goes this side, just use bare hand. It should be something like that, but trying to come up something clear when you draw using the graph paper. This one we can call it an ogive graph. What I wanted in Roman number 2. Then they said that using the graph ogive graph in Roman part B, Roman 2 above, calculate a quartile. Now how do you get a quartile? Quartile, we shall say that we must divide the item into 3, into 4 equal parts, whereby the quartile is equal to n divided by 4. N divided by 4. Now in that case, item. Now in this case, we are just going to have 40 divided by 4. We get the 10th item. Then we can talk of L plus I over F into M minus C. We bring this particular formula. Now we can identify where 10th is. It falls somewhere here. 10th. That is 1, 2, 3. 1, 2, 3. Meaning it is this particular free column of interest, meaning we are meant to take the 62 as the lower class limit plus, that was 4 over frequency. It was 4. Now frequency is 1, 2, 3, 4. That is 5. Frequency is 5. Sorry, frequency is 5 into 10 minus what? The one that is above, that is 5 minus 5, which is 62 plus 4 over 5 multiplied by 5, which is 62 plus 4, which I have 66. Now in that case, we can use this particular to identify. We wanted to using the OGIF curve estimate the value of quartile deviation. Now we identify where 66, this one, can come and then approximate this side, and does it fall under that particular. And then you record the item on this particular side. Then the model class in this case, we are taking the one with the highest frequency, which is 70 to 74. Now the model class in this case, we are just going to record 70 to 74 is our model class. Yes, that's how you are meant to take this from 3. You identify the quartile deviation. The quartiles, we are dividing the population or the total into 4 equal parts. That's why I did. I divided at this point by 4. But if it was the median, we could have used this particular, instead of 4, we could have used 2, because we are dividing the population into 2 equal parts. In that case, you do that way, you get yourself the 20 marks of question number 5.